All right, let's jump right in. This is a high-precision explainer on phase 1 of the CPMI methodology, and it's built specifically for those of you gearing up for the certification exam. You're experienced AI program managers, so you don't need the basics. We're going to get straight to the critical details you need to know. So here's our game plan. We'll start with the 7-step blueprint, then cover objectives and cognitive needs, situation and performance thresholds, the trustworthy AI guardrails, that all-important go/no-go decision, and finally, the project plan. We're hitting every task group exactly in order. Okay, phase 1. This is the big one. It's all about establishing the why and the what before anyone even thinks about writing code. And listen, this isn't just another section. It's a massive 41% of your exam score. So yeah, nailing this is absolutely crucial. And here they are, the 7 task groups of phase 1. You've got to know these cold for the exam, not just what they are, but their exact order. Think of it like a cascade. Each step logically flows into the next, taking you from a high-level business problem all the way down to a concrete, actionable plan. All right, let's tackle the first 2 task groups together. And you're going to want to lean in for this one, because this is a classic exam trap, mixing up the business why with the AI's what. We're going to make sure that doesn't happen to you. So first up, task group 1, determine business objectives. This is all about answering one simple question. Why are we even doing this? We are strictly in the world of business problems here, not technical solutions. The perfect exam answer is something specific and measurable, like we need to reduce unplanned equipment downtime by 30%. Simple as that. Okay, now for task group 2, cognitive project requirements. This is where we translate that business objective into what the AI actually needs to do. It's like we're defining the AI's brain power, but in plain English. So if the goal is to cut downtime, what does the AI need to be able to do? It needs to predict equipment failure. And here's a critical point for the exam. We are not talking about algorithms yet. That's way down the road in phase IV. Don't fall for that. And this right here just lays it all out perfectly. On the left, you have the why, reduce downtime by 30%. That's tied directly to business value, to ROI. On the right, you have the what. The system has to be able to predict pump failure. This is the AI's specific job. And that job points us toward a general type of AI solution, which the methodology calls an AI pattern. In this case, it's pretty clearly predictive analytics. See the flow? Business goal to AI capability to AI pattern. Okay, so we've got our why and our what. Now it's time to bring this thing down to earth. The next 2 task groups, assess situation and AI system performance, are all about facing reality. We're defining our constraints and, maybe more importantly, figuring out what good enough actually looks like in hard numbers. Okay, quick pop quiz because the exam will definitely hit you with this. There are 3 different types of performance values you need to know. Can you name them and tell me the difference? Let's walk through it and make sure you've got this locked in. Look at this table. It's basically a ladder of metrics. At the very top, you have the business success criteria. That's our reduce downtime by 30% goal from way back in task group 1. To see if we're climbing towards that, we look at the middle rung, KPI performance values. This is where we track a specific business metric, like downtime hours per month. And at the very bottom, the foundation, you have the model performance values. This is the technical stuff, F1 scores, accuracy, that your data scientists live and breathe. The key is how they connect. A great model score should improve the KPI, and an improved KPI should get you to your business goal. It all flows upward. Here's another one of those distinctions the exam loves to test. Think of it this way. Assess situation is like making your shopping list. It asks, what do we need? You list out the people, the skills, the budget, the time. Then, later on, execution feasibility, which is part of the go-no-go decision, is like checking your wallet before you go to the store. It looks at that list and asks, okay, can we actually afford all this? Can we really do it? One is the input, the other is the verdict. All right, let's talk about trustworthy AI. This is where we set up the guardrails for the entire project. We're talking about the ethical, legal, and safety boundaries. And let me be clear, these are not nice-to-haves. They are hard, non-negotiable constraints that will absolutely shape everything that comes after. I would bet money you'll see a question on this. Transparency versus explainability. Here's the easiest way to remember it. Transparency is like the owner's manual for your car. It tells you how the engine was built, what parts were used, the general principles of how it works. It's about the system. Explainability is like the mechanic telling you exactly why your specific car's check engine light came on. It's about a single decision. Macro versus micro, system versus instance. Got it? Okay, now we arrive at the big one, the AI go/no-go decision.
Think of this as judgment day for the project. This is a critical gate, and the key thing to remember is that it's all about synthesis. You're not doing new research here. You are making a formal, disciplined decision based on all the evidence you've gathered so far.
So, how do we make that decision? It's not a gut feeling. It's a structured assessment across 3 totally separate dimensions. Think of it like a 3-legged stool. You've got business feasibility. Does it make financial sense? You've got data feasibility. Do we even have the right data? And you've got execution feasibility. Can our team actually pull this off? If any one of those legs is weak, the whole project falls over. You can't prop it up with the other 2. So after looking at those 3 dimensions, you'll land on one of 4 verdicts: go, conditional go, modify, or no-go. And here's something you really need to internalize for the exam. A no-go is not a failure. I'll say that again. A no-go is a success of the process. It means you just saved your company a ton of time and money by stopping a bad project before it started. That's good management. So let's say we get a go, or maybe a conditional go. What happens next? We move to the final task group in phase 1, which is all about producing the formal project plan. Now watch out for this, because it's another one of those tricky exam questions. People think project plan and they imagine starting from scratch with a blank document. No way. This step is not about new work. It's purely about consolidation. You're just taking all the outputs from the previous steps and packaging them up formally. And this slide really brings it all home. Look at these inputs. You've got the business objectives, the cognitive requirements, the resources, the performance thresholds, the trustworthy AI rules, the go-no-go decision. It's literally a highlight reel of everything we've done in phase 1. This plan becomes the formal contract for the project. It's where everything gets locked in. I mean, this quote says it all, doesn't it? You could build the most technically brilliant, most profitable AI system in the world, but if it's unfair or opaque or unsafe, it's a failure. And that's the whole point of phase 1. It's a safety net designed to stop you from building the wrong thing or from building the right thing the wrong way. So let's end with one final brain teaser, the kind of thing you'll definitely see on the exam. The business case is fantastic, a total slam dunk. But you dig in and realize the data you need to hit your performance target simply doesn't exist. What's the verdict? The methodology is crystal clear on this. It's a no-go. And that really is the essence of mastering phase 1. It's not about memorizing steps. It's about having the discipline to make the tough, evidence-based calls when those different feasibility dimensions don't line up.